Welcome to the NITRD podcast, where we explore the cutting-edge advancements and collaborative efforts shaping the future of networking and information technology. For those of you that don't know, NITRD stands for the Networking and Information Technology Research and Development Program. Join us as we connect with leading experts, discuss the latest trends, and uncover how NITRD is driving technological progress across the nation. Stay tuned as we embark on this journey through the forefront of technology, innovation, and research.
Welcome to the next episode of the podcast series on artificial intelligence. My name is Stephen Lee from the Department of Energy, Office of Science, and I'm one of the co-chairs for the NITRD Interagency Working Group on Artificial Intelligence. For today's podcast, I will be the moderator for this discussion on the topic of human-AI collaboration. Joining me are three colleagues from the AI Working Group from NIST, the CDC, and NASA. To kick things off, let's have Mary, Jay, and Nikunj introduce themselves, explain the meaning of their agency acronyms, and their general interest in AI. Mary?
Sure. So my name is Mary Theophanis. I'm with the National Institute of Standards and Technology, and I'm a computer scientist by training, and I work as a senior technical advisor in the organization, and I'm a NIST fellow. My interests have always been in human-computer interaction, even before AI, but now with AI, that field has expanded and is changing quite dramatically. So I'm continuing to focus on HCI and what that means for AI and what that means for humans as this field expands.
Terrific. Jay?
Yeah, hello. My name is Jay Vitas. I work for the Centers for Disease Control and Prevention. And within the CDC, we have an organization called the National Institute for Occupational Safety and Health, where I am the chief of the Emerging Technologies branch. I'm an industrial hygienist by training, which means that I'm focused on worker safety and health. And kind of like Mary just described, my background really interests were all about trying to understand how technology really implicates on workers and their safety and health. But it really now, with the advent of artificial intelligence and the changing way in which work is going to be not only performed today, but anticipating what the changes will be in the future really drives my interest in the subject area.
Thank you, Jay. Nikunj?
So, hello, I'm Nikunj Oza. I am with the National Aeronautics and Space Administration, or NASA. Within NASA, I lead the data sciences group. We do research and development in machine learning for the full range of NASA problems. So this includes aeronautics, earth science, and space exploration. I have been interested in artificial intelligence really since I was an undergrad, probably because I was lazy at that time and imagined fully autonomous systems kind of doing everything for me. But then I did actually go on to get a PhD in machine learning. And then I joined NASA in 2001, and we started the data sciences group in 2002. And within my division, which is the Intelligence Systems Division, we've actually had significant artificial intelligence work going on since the division started, which was back in 1984. So it's wonderful for me to be continuing this actually rather long history of NASA work in AI. Thank you.
Thank you. I'll quickly note that the National AI R&D Strategic Plan was released in May of 2023, and myself and each of my colleagues here had a role in helping to write the strategic priorities to guide the National AI R&D Plan. So let's start off with a very basic question that I'll go around the room again. Can you describe what human-AI collaboration means to you? And we'll start with Mary again.
Coming from NIST, I'm going to take a measurement approach as a metrology lab. And so, I would argue that it's developing systems that can partner people and technology, AI in this case, to accomplish tasks that exceed the capabilities of either the AI alone or the human alone. So the outcome is improved performance, whether that improved performance is efficiency or effectiveness or some other metric that we'd like to measure. But realistically, we want improved performance. We want to exceed.
Thank you. Jay?
I echo Mary's sentiments in terms of it's about improving performance. But I also think there's a social element that exists there with respect to, humans work with humans as teammates, and that collaboration is has always been something we've studied. But now we're adding in really technology as somewhat of a human peer. And it's a fascinating area to be thinking about in terms of that give and take between those two parties. And really looking at, from a research standpoint, how do you achieve, as Mary said, those improved efficiencies and effectiveness alongside the human to, in some places replace functions of the human, but also really at the end of the day, how to augment the human as a unified or team effort.
Yeah, Mary and Jay's excellent points. And about the only thing I can think of kind of adding or emphasizing within that is that it's important for us to understand the human skills and skills of an autonomous system in pretty good detail. I mean, we know generally that they are complementary, but in what ways will they be complementary in different tasks? And then Jay also raised the important point that the humans and especially the humans, but maybe to some extent the autonomy, are maybe naturally going to have to adapt to each other because largely they have, especially humans, have largely worked with themselves, and there's a certain vibe and way of collaborating that they're able to do that is likely not going to be possible with humans and AI or autonomous systems.
And what about AI augmenting? Can AI always just replace what the humans are doing? How do you make that determination?
I think there's been a great deal of discussion on this topic. And I think the field or the domain itself is still trying to figure that out, right? I mean, and we just look at the different terminology that's being used to define the space, right? Is it human AI teaming? Is it human AI collaboration? Is it fusion? Is it delegability? Is it complementarity, which is, things that we've discussed already? Or is it the human in the loop? So I think there's this whole spectrum of teaming. And I don't think it will always be fully autonomous. I don't think it will always be driven by the human. I think we're moving towards some middle ground, but I do think it's very context and task specific. And so I think we'll see across the spectrum different tasks in different contexts employing the right approach at that time.
Nikunj.
Yeah, I mean, in general, we do have a sense that humans and AI are quite complementary in their skills. I certainly don't see AI blanket replacing humans in a large set of tasks. It's really going to be, as Mary said, it has to be very task specific. And we have some general ideas, like we know AI systems are quite good at processing massive amounts of data. They don't get bored with doing that. I think we talk about the 3D tasks, right? Dull, dirty, and dangerous. We want AI doing that sort of thing. But on the other hand, humans have their skills. They are still overall better at creative work and work that requires abstract reasoning. And they're also better at drawing analogies between different problems. But then, yes, we do need to get down into what is it overall that you're trying to perform, what is the overall problem, the set of tasks, and where humans and AI will play a role either individually or together.
Thank you.
Yeah, and I'll jump in and add, I really appreciate that Nikunj just described the dull, dirty, and dangerous, because I'm thinking about it from a workplace safety standpoint. Those are fantastic. We would love for it to be that we reduce or even eliminate some of those dangerous and dull and dirty jobs or dirty tasks that could harm humans. That's really a great opportunity. At the same time, there's great concern about jobs and tasks going away as a result of that are really something to make sure that we do from a big picture standpoint of helping people to either reskill or to upskill to maintain proficiency in their particular skill set, because I think that will be critical. I don't see let's say physicians going away or radiologists going away or computer scientists or industrial hygienists going away. But I think that the skills needed for those future generations of specialties will require an understanding of how to team with these artificial intelligence systems to be more effective in the work environment.
Can you highlight any human AI programs or projects that you're pursuing to make advances in this area?
Yeah, at NIOSH, we're trying to understand how technology in general is implicating on workers, both from a standpoint of reducing some of these tasks that are dangerous to individuals or to make jobs more safe in those environments using tools such as computer vision that can identify whether or not they're wearing safety equipment or they're in an area where they might be at risk. We're also using artificial intelligence to improve some of the research efforts that we have, trying to mine some of the databases to understand better trends that exist in some of our safety and workplace related databases that are there. But then from a human AI teaming standpoint, we're really looking at programs on how to safely interact, particularly between robots and workers in environments in which they're supposed to, effectively work as teammates, but particularly where they could collide with one another. And so anticipating the movements of workers, I think, is really critical to be able to have these teammates working alongside you, but not really get in your way or, in worst case, to harm you.
Human AI programs or project at NASA?
Yeah, one project we have where we're actually using machine learning to actually try to better understand how to do human autonomy teaming. And this is an effort related to commercial aviation that we have called Human Contributions to Safety. So there have been organizations and some people also who have suggested that human commercial pilots should not be there anymore. We need to make these fully autonomous. Yes, there is this statistic out there that among aviation safety incidents and accidents, that in about 80% of them, humans are at least partially to blame. But it turns out within that vast majority of flights that have no aviation safety issues, humans contribute positively in 20% of them. So prevents some kind of safety issue from happening. Now, given how safe the system is, actually a quick calculation led us to figure out that for every one time that a human contributes negatively to safety, they contribute 157,000 times in a positive way to safety. So the point is that if you're going to have autonomy in the cockpit, yeah, it's great to remove the faults that humans have, but you better capture that significant amount of positive behavior that they have. And so there are, of course, various methods we're using to try and identify those positive behaviors. But one example or one technique we're using is machine learning, actually, to look at flight recorded data and aviation safety reports to try and find what are those positive behaviors, what seem to trigger those positive behaviors, and therefore capture them. So if you were to then make the cockpit fully autonomous, you would capture that positive human behavior, or at the very least not get in the way of the humans implementing that positive behavior.
And Mary, how about NIST?
We have a couple of efforts going on. I think I'd like to highlight the biometrics program. We've had a long history in face recognition at NIST, and we continue to evaluate algorithms as well as people in their evaluation skills. And there's a group of people called super recognizers, and they have this excellent ability to recognize faces. And so there's been a lot of comparisons done between super recognizers and algorithms. And algorithms perform very highly today, but these super recognizers also do. What we've done is we've paired algorithms with algorithms to see if we can get two algorithms to improve. We don't see any improvement in that space. We've paired super recognizers together. We don't see improvement when we pair a recognizer, super recognizers. But we have seen improvement when you pair algorithms with a super recognizer. So this is that complementary aspect that I think Nikunj was talking about. And so now we're looking at, okay, how do we know who to pair and which algorithm to pair so we get the best improvement or the biggest boost? I think they're calling it a boost. And so this is really interesting, and it's applicable to many fields. I know that I read a couple papers where they've seen similar results in the medical profession, especially with diagnosing, looking at x-rays. I say x-rays, but looking at scans of mammography or cancer and partnering again. So you have these people who are really, really good at it, partnering with a good AI. We have seen improvements. So we're excited about that.
I'm thinking back to 2 summers ago when I worked with Mary and Jay on writing this strategy number 2 on effective human AI collaboration for the National Strategic Plan. I really learned a lot. And one of the things that struck me is that the emphasis is really on socio-technical research. That it's not just about building better, more powerful AI, but it's also the social side of things and how these systems get integrated with human teams. And things such as human factors and building trust certainly came up. I think we all use GPS systems and they do a pretty good job of guiding you to where you want to go. But sometimes you wonder, hey, is this taking me in the right direction or am I being fooled here? So I think it's similar to what we're now coming up against with AI systems. So could you say more about the social side of the research that needs to be done in terms of human factors and building trust? Any thoughts in that direction?
I think from a worker safety and health standpoint, that trust is really important. Your comment there about using GPS and, if you don't trust it, then you probably aren't going to maximize the effectiveness of that particular tool. And so it might cause more issues when you're driving. You might not get to the location that you really wanted to get to. The flip side is if you overtrust, you just blindly trust that the technology does everything for you and it's infallible, that you could have the opposite outcome occur where you end up driving into a lake, per se, because that can unfortunately happen with some of our GPS systems. So where do you find that nice balance? I think that the research really in terms of understanding trust, which is really a social domain, and pairing that again with the human and their trust nature, because it's going to be a little bit different for everybody. And calibrating that in a way where we get those optimized outcomes will be really important, particularly as I think about the use of these systems in workplaces day to day.
I think those were excellent examples. And, we do talk about how to improve trust. And there are a couple of ways to do that in systems, right? And one of them is the transparency and the interpretability or explainability of a system. But Jay's completely right. I mean, there's an automation bias in a lot of people. And if the AI says this, they're going to accept it. Then there are other people that are at the other end of the spectrum where it's like, oh my gosh, I'm not going to trust any automation. And so they don't. I think training is going to be important as we teach people to calibrate trust, to have the appropriate level of trust, and to question and look for that transparency, explainability, interpretability that are key trustworthy characteristics identified in this AI RMF framework. But you've got to work with those to level out the appropriate level of trust so that you can actually build a team.
Yeah, that's very true. I think one other issue also is, how do the humans work with the system, the interfaces? I know there was some discussion at the start of the pandemic when we started working offline more that it felt weird talking to a computer, that people sometimes had difficulty with that. I know I can't get myself to talk to any of the voice assistants that are out there in different phones and other devices. So I wonder what kind of research maybe would be relevant here to figure out what it would take for humans to transition to working with increasingly autonomous systems in different kind of tasks, and what it really takes for them internally to kind of get used to that interaction with one or even more autonomous systems.
I'll follow up because I think that's interesting. I think, Steve was alluding to the fact that this is a very multidisciplinary research area. And I think you just hit on it. I mean, we need sociologists, psychologists, decision theory experts, cognitive scientists to take their great depth of knowledge in this trust space and other spaces, but trust in particular, to help build those trust relationships, because there are best practices in teaming, human to human teaming for building trust. Can we take those best practices that those fields have already developed, and do they apply in this AI teaming relationship? Some are quite simple in our lives, but do they apply? I mean, one, for instance, is you constantly repeat a person's name. And so as you repeat that person's name, you're building that trust relationship. You reciprocate actions, right? I mean, can we do something similar to that in an AI teaming environment to help build trust? Will that work?
Mary, that's such a fascinating thought to that we can build some of these systems to do exactly what you're describing. But I also think the beauty of AI is that you can customize this for the individual. And so as you learn more about these systems, you can take into account some of those personality differences. You may not like to have your name called over and over again as much as somebody else does. And so tuning it can be done, but it requires, again, this multidisciplinary approach to understanding the factors that go into building that trust and teaming that's essential for that effective output that we're really looking for at the end of the day.
More on the technical side of socio-technical, one of the research strategies that was led by Nikunj was strategy number one on long-term AI research. This is still early days for AI, and there's a lot of other important research to be done to advance these AI systems. We finished the writing more or less 2 summers ago, summer of 2022, and then ChatGPT comes out in the fall of 2022. And I was worried we'd have to rewrite the strategic plan, but we made some updates. But it seemed that this mode of human AI interactions via chat was a game changer. And I'm curious about any of your reactions if you've tried ChatGPT and interacted with it and maybe collaborated on it for something, and what that might mean for us as a nation.
So, yeah, I will just mention I actually have had very little interaction with ChatGPT so far, or any other such models. But one thing I've noticed is it seems, at least in what I've seen, that there's only discussion of one-shot interaction, so to speak. Like, say, I'll ask a question, see what its answers are, but not then have a reply back where I then have a follow-up question and then it replies again, and kind of going back and forth, maybe to refine some single point, but then maybe even to go on, let's say, to multiple points. One can imagine, let's say, maybe using it to work on multiple chapters in a book where it's different facets of the same kind of large problem. I would be curious to see maybe if there is work of which I'm not aware that has been done on this, and maybe what more could be done from this kind of multi-shot interaction. Is there a point of diminishing returns, et cetera?
Well, that's interesting. NIST has, we're I say just started, but we've been in the process of developing a program, ARIA, and it looks at generative AI. And one of the things that ARIA is looking at or focusing on are some of the concerns and issues with generative AI. And one of those is truth. We have a couple projects that are looking at that, right? So when it generates something, terminology has changed, but it started out with it can generate hallucinations or provide hallucinations. Now I think the term is confabulations. But, how does a user, back to this trust, how does a user understand if there's truth in the results and then take it or leave it? But, we need a truth finder in some bizarre sense of the word. And so we're setting up some tests to examine the output. And, if you ask a set of questions and I don't know how deep we're going to dig, but I do believe it's more than one. And can you end up in an area where it's just hallucinating or making up data?
Yeah, I'm amazed at all these generative AI tools, whether it's ChatGPT or Claude or some of the other models that are out there. And to Mary's point, it's impressive what it can provide in terms of outputs. It seems incredibly confident in its results. And that is also then when you do the fact checking, you find out, as Mary just pointed out, whether it's hallucinations or confabulations or whatever you want to call it, it makes errors. And I think, again, how do we figure out how to use these tools as a team to make us more efficient? Because sometimes it's pretty impressive. For example, if you're writing code, if you give it a prompt and it provides you a response, it's usually a good first start. It's not perfect. It usually needs some customization, but it's a good beginning. But you need to know that. If you didn't trust it at all, you wouldn't even ask it for code. So that's not good. But if you overtrusted it, then you would end up with a mess, and that's not good either. So again, it gets back to this: how do you find that optimization that's really going to work for you? And it takes, I think, some practice and playing and training, and as well as really thinking about it from a design standpoint. I think it's really critical when we think about these tools being almost in every facet of our life as we move into the next decade.
That's a key point about the trust. And the flip side of that is being fooled into thinking that the AI is like another person. So I mentioned at fall of 2022, you could type into a chat box and get replies. But now you can actually talk and it can reply in someone else's voice. And you can have an interaction and a conversation. And some people start to think this is alive. It has feelings. It's a sentient being. How do we guard against something like that? I think that's a tremendous challenge. And I also know that some agencies are doing red teaming or tiger teams and working out what that process looks like and asking that such exercises be done before a model is publicly released. I think that's where we are at the moment.
Yeah, I know, I agree. ARIA, that I was talking about earlier, has a red teaming component looking for guardrails, right? So what are the guardrails? Where should they be? What should they encompass? And does the software, if you give it a set of guardrails, does it stay within its guardrails, or can people circumvent them to get to other information or to get to this being or just to believe it's a sentient being or whatever? But yeah, I mean, I think red teaming it, I think multiple types of testing are critical in this space, right? I think you need the red teaming to address one part of the problem. I think you need field testing to understand how users work with it in quote unquote more normal situations. And then I think you need expert technologists to test the operation of the code or the performance of it. So I think testing is a huge area in this AI human teaming space as well.
Terrific.
Yeah, and at NIOSH, when we're looking at this red teaming concept, which really is about finding flaws and vulnerabilities in these systems, we use the thought process of what could go wrong, what can really potentially harm the worker, and that really being the way that you at least prepare, because I think that's part of the challenge is how do you prepare for maybe the system not doing what it's supposed to? And I think it's essential for us to recognize that these are just software and hardware poised together, built by humans, and they are potentially going to make mistakes. And it's important for us to recognize that we anticipate what those mistakes might be and really address the ones that are going to be of most significance and recognize that some of the ones that are less significant might not hopefully impede us using these systems, but we work with others, particularly software programmers and the like, to be able to address those flaws.
Okay, let's look ahead a bit. I want each of you to pull out your crystal ball. How do you envision the future of human AI collaboration evolving over the next decade? I just mentioned that, we first started out, typing into a chat box. You can now have voice-enabled conversations with AI systems. What's the future look like, or is it too soon to say?
Well, I think the bright future would be that humans are so much more effective and that we end up solving some of our major challenges because we are able to focus in on those most important issues that we as humans need to address. But I also think we need to be guarded about the future that is more dystopian in terms of that we allow these systems to be in charge, that there is no human oversight of these systems, that they are the ones that are dominating the equation, and that they're the ones that are optimized on, as opposed to the outcomes that we're really interested in. And I'd say not only from an individual level, but really thinking about it more from an organizational, societal level, which I think is really critical.
Nikunj?
Yeah, so one area I at least hope that human AI collaboration evolves over the next decade or more is really for humans and AI to better observe each other and really learn from each other, and maybe sometimes even do like what we see human pilots sometimes do, where if one is heads down in a certain task, then the other one will just kind of automatically take over certain functions, really getting that kind of learning from each other, interacting with each other. We have some small steps in that direction, really, with some effort we have within commercial aviation using machine learning methods to look for anomalous data, which could represent potential safety issues. But there is the problem of false alarms there. So we have domain experts, safety analysts who actually go and label those examples either as being potential safety issues or not. But of course, there's limited domain expert time. So we have brought active learning to this problem. So we try to choose which are those few examples that are going to give the biggest bang for the buck, so to speak, in really lowering that false alarm rate. But then we hope, of course, that the anomaly detection algorithm then is learning from the human then. But then can we imagine operationalizing on this, maybe kind of going back and forth, getting better and better, maybe even talking about not just, okay, this particular flight in this situation was or was not anomalous, but what if you change the conditions just a little bit? How much does that actually change, whether you consider it a safety issue or not? Can we maybe have the humans and AI go deeper into a problem in this way?
Yeah, no, I agree with that completely. And I think we need to focus on what is it? What are the weaknesses and strengths of both humans and AIs, right? Because they're complementary. We talked about humans are slower at the large tasks where you have to do a bunch of repetitive things, right? They get bored, they get fatigued, they're distracted. There's human error. Yet, our strengths are creativity. And I guess one could argue that the generative AI has some creativity, but again, it's all pattern matching. We're not going to get new, maybe, ideas or new art forms. They're not known to make those big leaps. Humans are relational and empathetic and can read those signals and read that context, whereas AIs are generally not good at reading that context and understanding that emotion. And yeah, AIs are really good at a complicated task that they've trained for, but they can't generalize that yet necessarily to other situations where the factors don't line up exactly or the characteristics don't line up exactly. So I think that in the next X years, X being short, 10, like you said, I think we will see a lot of teaming. And I think we're going to look at this complementary aspect of it, where we build on the strengths of the human, we build on the strengths of the AI, and in the end, we get a better output.
Mary, Jay, Nikunj, thank you for sharing your insights. I think it's fair to say we're all on a steep learning curve for AI system R&D and human AI teaming. It is one of the priorities in our national AI R&D strategic plan. And I think this podcast really helps us to continue that conversation. To the audience, we hope you enjoyed the conversation, and thank you for tuning in.
Thanks for listening. Please subscribe to our podcast so you never miss an episode. Visit our website at NITRD, NITRD.gov for more information and additional resources.